Today we're going to look into density. Density is a characteristic property, a way to tell different materials or different substances apart. To start, look at these three different pictures of fog. What are some ways that you would describe the fog? It's a thick fog, it's hard to see through. Now look at these different pictures of forests. How would you describe them? The trees are very close together. If you were walking through the forest, it would seem really dark. You might even say it's a dense forest. The passengers on the bus, we could say, are very crowded. They're close together. They're densely packed. The people are densely packed. So think of some other words that are synonymous with the word dense: crowded, close, crammed, squished. So let's look at these two different objects, um, A and B. So first question, which object's bigger? Trick question, they're the same size. If it was a three-dimensional object, we'd say they have the same volume. So which object, A or B, has more stuff? If the blue dots represent molecules, we would say that A has more stuff. If each dot has the same mass, which object has the more mass? So if these were molecules, since it has more molecules, A has more mass. So once again, just visually looking at them, we would say A is a denser object. Even though they're the same size, A has more matter, more stuff. Okay, it's a little trickier when you have objects that are dissimilar in size. We cannot see molecules, so we can't really just look inside the object to see which one's denser. We could do something by finding the mass of the objects, however, they're different sizes. That wouldn't really be fair. So what we would like to do is to cut the same size sample from each piece. And then we could simply find the mass of each piece. So let's say these were each 1 cubic centimeter pieces of the material. Then we could just mass them, see which one's heavier. That would be the one that had more matter. However, we don't want to go about actually physically cutting these things. But if we could find the mass of 1 cubic centimeter, that would tell us which one's more dense. So if we look at this chart actually shows us 1 cubic centimeter samples of different materials and what the mass is. So silver, pretty dense material, 10.5 grams. Aluminum, not so dense, 2.7 grams. Water, 1 gram per cubic centimeter. Liquids are pretty similar to water. Some are more dense, some are less dense. The freak is mercury. It's a liquid, very dense, 13 grams per cubic centimeter. Gas is very low density, about on average 500 times less dense than solids or liquids. So once again, density just measures the mass of a 1 cubic centimeter sample of the material. Okay, since we don't want to go about just cutting 1 cubic centimeter samples, we can do some pretty simple math to find density. But let's do a quick math review. Cindy went to the store, bought 40 cookies. She goes to school the next day. She has 20 friends. How many cookies per friend? We love cookies. We can do this easily. 40 cookies, 20 friends. Some simple division, 2 cookies per friend. That's how simple the density calculations are going to be. Once again, we want to calculate the mass of 1 cubic centimeter of this material, but we don't want to cut the material to physically measure it. We know the mass is 40 grams. We know the volume is 20 cubic centimeters. We want to know the mass of 1 cubic centimeter. So once again, it's some simple division. 40 grams divided by 20 cubic centimeters would be 2 grams per cubic centimeter. Just quick review of density. It describes how compact or smushed together stuff is in a material. It can be measured since we can measure mass and volume. It measures how heavy something is for its size. If you pick up something that's dense, you'll think, whoa, this is really heavy. But what you're really thinking is this is heavy for its size. Density, you could say, is just the mass per cubic centimeter of material. And density is simply mass divided by volume. Kids sometimes get these confused. Oh, which order do I do it? Do I multiply? Do I divide? So you will learn to love density. So we're going to draw the heart for love. We're going to draw the arrow going through the heart. And as you can see, if you draw the heart, mass divided by volume. That's as simple as density is for calculating density. Okay, last thing, a couple practice problems. In which box is matter more dense? Once again, remember density is simply finding the mass of a single cubic centimeter of material. So we can see that box A is bigger than box B. Sorry, those are supposed to be the same size. All right, so when we do this, you always want to start with the formula. So for box A, density, that's a D. Density equals mass divided by volume. I'm going to substitute in the numbers that I know. 60 grams. I'm going to always write my units. Divided by 20 cubic centimeters. I don't even need a calculator for this one. 60 divided by 20 is the same as 6 divided by 2. So box A, the density is 3 grams per cubic centimeter. So if I were to cut my box, so I'd have a 1 cubic centimeter sample, it would weigh 3 grams. Okay, for B, going to do the same thing. Always start by writing the formula. The more you write it, the easier it'll be to remember. Mass divided by volume. Substitute in my known values. 40 grams, just waiting for my hourglass here. Okay, 40 grams divided by 10 cubic centimeters. It's a smaller box, smaller volume. And that gives us 4 grams per cubic centimeter. So in which box is the matter more dense? The higher number is the denser item. So box B is more dense. All right, thanks for watching and good luck on your quiz.